The next dosage form is phytosome. Phytosome sounds similar as that of liposome. Phyto is synonym for the plants and soma or somes again body or the cells. So in a phytosomes, plant extract is entrapped in a phospholipid. Again, it is also a carrier system, but it is little bit different. Don't worry, we are going to study the difference between liposome and phytosome. Right now, we will study phytosome first. So, how exactly we are going to entrap the plant extract in phospholipids? Reacting the herbal extract in a aprotic solvent with the phospholipid dissolved in the same solvent. Means we are going to take extract, we are put it in a aprotic solvent. At the same time, we are going to take phospholipids and we are going to dissolve it in the same solvent. Herbal extract in same solvent, phospholipid in same solvent. After solubilization has been completed, the complex compounds are isolated by removing the solvent. What we did? We made reaction of herbal extract with phospholipids in same solvent, that is in a single solvent, that is aprotic solvent. After solubilization has completed, the complex compound which is formed by the reaction of herbal extract and phospholipids, they are isolated by removing the solvent. Thus, the obtained complexes are lipophilic in character and are soluble in polar and aprotic solvent. And the point of interest is that the polar aprotic solvent means the complex is soluble in a polar and aprotic solvent. In that solvent, the individual components of the complex are normally insoluble, but when they form the complex, they becomes soluble. So this is the phytosomes. So drug, phospholipid and complex. In liposomes, the phospholipid structure we had seen as this, but in phytosomes, we said that herbal extract reacting with the phospholipids, plant extracts are entrapped in a phospholipids. Hence, we had shown phospholipids drug and it is entrapped over here and they are forming such a cell-like structure or a particle-like structure, or we can say membrane-like structure. Hence, they are considered as a called it as a phytosomes. What is advantages of phytosomes? Again, phytosomes can give protection against the destruction by digestive secretion or enzymes. Proper drug delivery can be carried out on the site of action. The nutrient safety of herbal drug is retained, as well as reduction in dose, enhanced absorption, again bioavailability. So all these can be possible with the phytosomes also. Entrapment efficiency is high as well as it is predetermined. Chemical stability is there due to the formation of bonding. In case of liposomes, there is only entrapment, there is no any bonding, while in a phytosomes there is a little bit bonding and hence its sustainability or we can say stability is more, as well as they have greater clinical benefits. So likewise, these are the various advantages, my dear students. Try to remember these advantages as they are very much common. That's why I haven't included them in my slides, but at least you must be aware about these advantages, or you may note down during these presentations. Applications. Okay. Method of preparation for a liposome. Before application, we will discuss little bit method of preparation. In that, The extract is dissolved in organic solvent like methylene chloride as well as dioxazine or ethyl acetate, and in the same solvent the phospholipid that we said that the extract must react with the phospholipid. So extracts are entrapped in a phospholipid. So phospholipid like phosphatidylcholine, phosphatidyl diethanolamine, or phosphatidylserine. So these phospholipids are reacted with the extract, and then after the solvent, once the complex is formed between lipids and extract, so that the complex has been isolated by removing the solvent. Like the solvent can be removed by vacuum or by freeze drying or by precipitation with non-solvent like N-hexane. We can add the N-hexane or these aliphatic hydrocarbons, and there will be precipitation of these phytosomes. So this is the simple method of preparation. So what is the difference? As we said, liposomes, here is the structure of liposome and here is the structure of phytosome. Liposomes, they are going to act as a carrier and they are going to entrap the drug molecule. However, in a phytosome, the drug molecule is, we can see, reacted and entrapped in a phosphatidyl head or that lipophilic head. So this is the greatest difference between phytosome and liposome. This is the difference between, as this I had shown, means in this diagram there is shown that it is a bilayer, but even though you can draw a single layer of means this particular lipoproteins, sorry, no, not lipoproteins, the lipid layer, hydrophilic head and lipophilic tail. Application of phytosomes. So silymarin phytosomes has been prepared, which shows improved bioavailability, lipophilicity, and due to it, its therapeutic effect is being increased. As well as green tea. Green tea, we are all are aware that green tea contains antioxidants, and hence it leads to the several effects like anti-cancer. So improved bioavailability is possible with the phytosomes prepared by the green tea. Quercetin, you all are aware, quercetin as well as curcumin, ginkgo. So all these drugs we studied, and my dear students, all these drugs, phytosomes are being prepared, and all these drugs, they had shown improved activity in the form of phytosomes.